Hello, friends. A big hello to all of you out there on the social media. And also, I take the opportunity to thank many of my friends who actually walked up to me and asked me to do a session on this particular topic. I have extensively dealt with AUTOSAR and introduction of AUTOSAR in many forums, and I have also dealt with extensive trainings when I was running my training programs to many corporate companies. Now, with an experience of about decade in AUTOSAR, today I'm going to talk about just the introduction of AUTOSAR. I'm not going to touch upon those very depth details of AUTOSAR, but I'm going to touch upon those very subtle elements of introducing AUTOSAR to engineers, which I believe, if understood well, will lay a strong foundation in understanding the subject further. So, without any more delays, let's get into the topic. Now, I just want to give an exercise. As a buyer, you are about to buy a new LED TV, and if you can sit down for about 30-35 seconds. I have written 5 minutes because in most of my trainings I used to give about 5 minutes, and I used to have an extensive discussion around this topic. But today, for the sake of being online, if you can make up a list of things that you would look for in a television in about 30-35 seconds, or even you can make a virtual list in your mind, but in the end of 30-35 seconds I'll come back to you and you will understand why I am asking you to make this list. Alright, I'm sure you would have written all those features that you are going to look for, or at least you would have made a virtual list in your mind which you can recall for the sake of our further discussion. Now, majority of you would have touched upon things like I need a flat screen, I need a full HD, 420k, or I would need a smart television, I should be able to connect to internet, I should be able to watch Netflix, I would Amazon, whatever. But then majority of you would not have listed these things that I show on this slide. It has to work with AC, it has to work with 230 volt single phase, it has to have a 2-pin connector, 2-pin plug, it should work in your hall and living room both. We have thought something like that. It should have a power switch, it should come with a TV remote. None of you would have listed all these things, or most of you, unless you are extremely crazy and already had an inkling of what I'm going to talk about, would have listed all these things because of a reason. Of course, all of us want a TV remote, even though it's the most essential thing that we want to get when we buy the TV, we would never have listed that. Why? The answer to that is, what was it that made these things implicit? The answer to that is standardization. Because we subconsciously know that these things come as a standard offering in any television that we are going to buy. These things are completely standardized. The socket in my living room and the socket in my any other room is the same. It's going to be the same. I'm not going to have two different sockets that has been put up in my house, which I will have to find adapters for plugging the TV everywhere. So I don't go and ask him that my TV has to work in my kitchen or bedroom or living room. No, I know that it's a standard socket that's going to fit into any of the electrical panel that I'm going to have in my house. I'm sure that this television will work in a 230 volt AC, unless I have imported it from some other country for the sake of importing, but otherwise we know all these televisions come with the standard offering. We definitely know that every television today has a remote that's going to come with it. Even though remote was most essential, we did not list it because we subconsciously know that it's a standard offering and it is going to come with any television that we are going to buy. So the answer to the question is standardization. And why did I give this example? Just record this in your mind. I'm going to come back to this. Now, there's one more scenario that I'm going to ask. And by the way, sorry for too much of text in my presentation. I did it in a very quick time, so I couldn't find too many images in a way that I can convey the message. So please bear with the text on my presentation, but I am sure the details on the slides are going to help you understand subject in a better way. So the scenario is like this. This is a business owner who is coming and asking his software team to say, okay, can you please implement a certain functionality? For the sake of simplicity, I have used the seat belt reminder as a functionality here. And the software engineer comes back and says, okay, I can do it, but then there's a huge estimate that I have. It's a substantial amount of time that I would need to do, because the IO configuration in my software is so rigid. I'll have to do a lot of changes there. I'll have to put a new task into my scheduler. My scheduler is hard coded, so I have to really modify my entire scheduler, put in a new task there, and a whole lot of things. And then he says, okay, this is the amount of time and money that I would need to implement this particular feature. Now the problem for the business owner is, I just asked for a very small feature that's going to add value to my customer, but unfortunately you're talking about a lot of other things which doesn't seem to be adding any value to my customer. The business owner thinks that all I asked him to is just blow an LED and just blow a buzzer whenever a buckle is not put in. How difficult is that? Now the software engineer says, yes, but in my software architecture, whatever I have, the LED and buzzer cannot be controlled without the changes I told you. I mean, it just doesn't come free of cost. There is whole lot of connected changes that I will have to do if I have to deliver what you asked for. Now, both these guys are right in their own perspectives. So none of them are wrong. They are right in their own perspectives, but still there is a huge gap between what the two people are expecting. And why is that gap? Let's see that. So what is the gap here? For a feature owner or a business owner, the ECU is something that he perceives like this. He or she looks at like this. An ECU or electronic control unit is something that does a lot of features, soft features, which add value to his or her customers. But for an engineer, the same ECU is, yes, it has features, but to make the features working, he has to deal with lot of software layers, which goes from just above the hardware until the feature layer. There's whole lot of software which are MCAL, ECU abstraction layer, OS, whatnot, which fills between the hardware and the feature layer, and an engineer will have to deal with those layers of software to provide the feature that a feature owner is asking for. So this is very similar to the point that if even though I know that I have made up my mind during the school days I want to be in science and pursue science or engineering as my career, still until I reach my 10th grade and come out of it, I will have to deal with languages, social studies, etc. I don't have an escape from there, because it's a basic necessity of the process to actually get to where you want to get to. And it's the same case here, that the feature owner is just looking at the final output, but the engineer is looking at what it takes to be done, or what are the modifications that needs to be done to get what the business owner or the feature owner is asking for. So that is where the gap comes in. So what is the solution? So this being the gap, what is the solution? One thing that OEMs observed was this pain was very common across all the OEMs and even tier ones. They wanted to add features, they wanted to spend money on implementing things that added value to their customers, but then in most of the organization, people asked for doing whole lot of other things which the business owners thought as overheads, and the problem was same in most of the OEMs. Initially, each engineering team started standardizing the lower layer in a way that they can reuse it to new ECU development. Now the companies individually started seeing it, so they thought, okay, you did the driver layer last time, why can't you reuse the same driver? Somebody thought of the idea of reusing. So what they did was they developed a standard stack for their own organization, and they started reusing that standard stack for any new issue development, so that they substantially reduce the effort of changing the middle layer software too many times and saving a lot of time and money. But still it was not good enough, because one particular team will have to sit down and maintain that particular complete stack, and if there is any change that one particular ECU is requesting for, then the change has to be suitably adapted to all the other ECUs, which by itself was still a pain. OEMs and tier 1s realized that this need not be done within their organization at all. At some point, someone said, you know what, why should we have all these guys sitting here trying to maintain this middle layer software? Why can't we have somebody else sitting and doing it? And then the standard was developed, and somebody else thought, okay, if we have to have somebody else do it for us, let's standardize it. We cannot have 200 people sitting and doing 2000 different things for us. Let's have at least 5 to 6 different people who can do a certain thing in a certain way, and that certain thing has to be a standardized or a standard that is written which is suitable to all the OEMs. And that is how AUTOSAR was born. The OEMs and tier 1s saw that there was a pain point. They all came together. They wanted to have a standard written of how their middle layer software should be. When I say middle layer, I'm talking about the software which starts just above the hardware and reaches up until the feature. The feature is a logic that each OEM will have of their own, but something which is in between the feature and the hardware. That complete set of software, that is something they wanted to standardize, so that they end up spending more time on determining what is the feature that they want to implement. This is very similar to the example which we started with, where right now you spent most of your time in thinking what are those necessary features of your television, be it HD or be it color, what kind of smartness it should have, what kind of connectivity, what should be the size, etc., rather than thinking about very basic things like what kind of connector, where should it work, how should I plug it in, which was not probably something that would have added too much value to your buying experience. But now, since those things are standardized, you are spending more time on choosing those things that add a lot of value to you. It's a very similar case that OEs and tier 1s started seeing their problem, and they saw that once something is standardized, they can actually start concentrating on things that matter most to them. And that is how AUTOSAR was born. Welcome, AUTOSAR. Now, what is AUTOSAR? So AUTOSAR is probably an acronym which says Automotive Open System Architecture. It's jointly developed by automobile manufacturers, suppliers, and tool developers. There are more than 100 member companies. If you want to know the details, just visit www.autosar.org. All the details are available in that website. It paves the way for more innovative and complex electronic system for better performance, safety, and quality. It's a key enabling technology to manage the growing complexity, facilitates the exchange and update of software and hardware, which we are going to discuss in a while how. But on the whole, the mantra has always been cooperate on standards, compete on implementation. So where OEs and tier 1s come together to develop a standard which is agreed by all, and then they go back and they try to better each other in the way they implement and use this particular standard. That has always been the mantra of AUTOSAR. Now, what is the scope of AUTOSAR? Technical scope. In a classic way, dealing with memory, dealing with communication, dealing with diagnostics, ECU, ECU abstraction, complex drivers, and microcontroller abstraction, etc. These were perceived to be the most important scope of AUTOSAR from a technology perspective. But there were some newer concepts which was found to be very useful, something like virtual function bus, RTE, configuration concepts, error handling, input templates, etc., which proved to be very effective and efficient for OEMs, which also became the core part of AUTOSAR that we see today. So let's discuss what are the benefits of AUTOSAR. If we understand the benefits, we will get a fair idea of why majority of the companies want their ECU to be AUTOSAR based. Now the challenge that most of the companies started with, as I said, was maintaining such a big requirements for such a big software. Since each software was very specific to the ECU and to the OEM, there was a big bunch of requirements that they had to really maintain. Just for implementing a seatbelt reminder, they had to really maintain which IO pin, what configuration, which task, what configuration, where was the scheduler, whole bunch of things written in the requirement for somebody else to understand. And for all the features that was there, maintaining such huge bunch of requirements was not really beneficial or was not even very practical to maintain it in the best way. The moment the middle layer was standardized, there was whole lot of benefit that the OEs could reap out of it, and they started maintaining a balanced and well written requirements for their features, which was what was adding value to their business. There was a lot of effort wasted on implementation and optimization of components which added no value or not recognized by the customer. Like for example, when I say I would like to optimize my memory handling, the customer doesn't care. All the customer wants is when he cranks, the car should start and he should be able to move. And when he presses a button, he needs to see the light. When he on a cruise, he should be able to cruise, etc. He doesn't really care how do you manage the memory, how much RAM you have, how much flash you have. That's of no importance to them. But in a classical world, majority of the time were spent by the engineers doing these kind of things. Now again, standardization and putting a basic software in place ensured that engineers started spending most of their time thinking about the features and implementing the features rather than things that did not really matter to the OE. End of life was one of the biggest challenge. Go to any semiconductor company today and try to get a clear answer as to till what extent will they continue to provide a particular microcontroller. The chances are that you will not get a definite answer because the industry itself is very dynamic and it's so vulnerable to the market needs, etc. Sometimes chip manufacturers stop selling certain products even though it's so important for certain companies, and when that happens, these OEMs or tier 1s are forced to change the microcontroller or the peripherals on their ECU. In a classical world, when such a change is made, it is rather too difficult for somebody to port that complete software into the newly developed hardware. But when you have an AUTOSAR based things, all your features are intact because they have standard interfaces into your AUTOSAR layer. All you need to do is you pick the MCAL of the new controller that you have chosen, plug it into the basic software, and then you can completely port your existing software onto the new ECU. Of course, it's not as easy as I say here, but at least the belief is that the advent of AUTOSAR made porting much more easier than what it was in a classical development. Large effort when relocating functions. Now if I for some reason, I'll give you an example. Let's say you have two ECUs, one is completely overloaded but the other is completely empty. Now you don't want to put more functionalities into this ECU which are overloaded, but unfortunately your architecture is designed in such a way that it's so rigid that it's too difficult to move some of the components from ECU A to ECU B, which will cause a lot of complications in determining how the business should move on. In such case, sometimes each companies have added additional hardware unnecessarily to quickly overcome the problem. Such problems are easily overcome when you have a standardized software in between. Especially AUTOSAR is something, the standard that is taken care that porting of a particular software component. In fact, in AUTOSAR world, software component means a small logical block. Porting of a logical block from one physical ECU component to another physical ECU component is way too easier compared to a classical software development. Non-competitive functions have to be adapted to a VOEM specific environment. Tiny little innovation, mixing clear interfaces between basic software and code generated from models. All these were a lot of challenge and problems in his classical development, because once you rigidly code it into your, weave it into your, or probably stitch it into your ECU environment, it was too difficult to make any further changes. Excuse me. But today, since we have a standardized AUTOSAR layer in between, it is rather too easy to make these changes, and it gives lot of flexibility for OEs and tier ones to concentrate on those very subtle things that add value to their business. Now, this being the benefits, let us look at what are the roles that are involved in different kind of companies where engineers do work related to AUTOSAR. Now, why I included this section, it was very important for me to include this particular section, because the kind of role that is played by engineer in a, say, OEM or a tier 1 compared to what he or she would play in a company which develops an AUTOSAR stack is not the same. And this is something that we all need to very clearly understand to really know what kind of work or role that one is getting into when we say it's an AUTOSAR related role. So starting with an OEM or a tier 1, if you get hired as an AUTOSAR engineer into an OEM or a tier 1, probably it's these one of these three things that you would be doing. If you are a very experienced campaigner, then you might be the system designer, because in a completely AUTOSAR based system, the signals have to be very well determined as to which component is going to send which signal and which component is going to receive which signal. And when I say component, I'm not talking about the hardware component here. It's going to be those software logical components where you determine what is this particular logical block going to do, what is it going to give as an output, and who's going to use this output, and you actually end up designing the complete system. So a system designer is somebody who's going to put the complete blueprint of the software architecture in an AUTOSAR based system. While this is a very rare or a very core of the roles that you might get, the other two very common but still most important roles that one may play in an OEM or a tier 1. The first one is the software component provider. This is simply the person who's going to implement the logic of the functionality. Now, let's take the same seatbelt reminder as what we talked earlier. The seatbelt reminder is going to have a requirement that when the buckle is hooked up, don't do anything, but when you see that the buckle is not hooked up after a certain speed, you're just going to glow an LED in the instrument cluster and you're going to just make noise out of the buzzer. Now somebody has to put this into the code and implement this as a software component or a logical component. So you could be somebody who's going to do that. Probably somebody is going to do both functional requirement and then implementation. Different organization deal with it differently. But then the other very important role, or probably the most common role that you might get into in an OEM or a tier 1, is that of an ECU integrator. Now the moment you are an ECU integrator, you are responsible first is to configure the basic software according to the requirements of your organization. Now when I say that the standardized layer of AUTOSAR is not completely hard coded, it cannot be. There are certain flexibilities that need to be provided for the OEM to configure it according to their requirement. So those things are actually given as configurable parameters in an AUTOSAR stack, and usually the implementers of AUTOSAR would provide you certain tool chain using which you can configure the basic software according to the requirements of your organization. Now that is the first task of the integrator, and next he or she is going to take the software component that is developed by the software component developers, connect them into the signals according to the signals that is determined by the system designer, and then he is going to put the complete software together and then get that one executable which is going to run on the target. He or she is going to be the responsible person to put all the pieces of software together, including the generated files after the configuration, and come up with that one single software that is going to run on the target. So that is why an ECU integrator's role is a very crucial role in an OEM or a tier 1 when it comes to the AUTOSAR domain. Now the other part is when you're working in an organization that develops AUTOSAR stack. Now here you are somebody who's going to have an extensive understanding of the AUTOSAR standards. Compared to OEM, you need not be an expert in understanding the standards written in AUTOSAR, but if you are an implementer of AUTOSAR stack, you should be someone who has a very good understanding of the AUTOSAR standard, especially for those modules for which you are trying to do the implementation. There will also be certain front-end developers who will be involved in developing those tool chains that are necessary to support the configuration and integration of this complete stack, and then the integrators are going to actually put this together into a system integration package which is then ready for another OEM or a tier 1 to be used as a user. Now that is where you need to really understand working as an AUTOSAR engineer in an OEM and tier 1 is completely different from working as an AUTOSAR engineer in a company that develops AUTOSAR stack, or in another company that is working to them as a supplier. So be very assured you really understand what kind of role that you are getting into. Now coming to the actual AUTOSAR software layer, in a very laymanish idea, this is microcontroller or the hardware or the ECU that we call in the AUTOSAR domain. This is more like our empty laptop. Now this application is something that we are interested in, the features of the vehicle that we are interested in. In our example, let us say this PPT executable or the PPT application that I want to run. Now this is something that is completely sitting in between as the device drivers in the Windows OS. Now imagine if these two guys, the Windows OS and the device drivers, were not present, and I have to put all my technical skills to make the PPT work with my hardware. I'm going to take years to just get couple of slides running on my screen, and that is not what a person using a laptop or a computer is interested in. The person using the laptop or a computer is interested in actually opening up the PPT as an executable and doing a lot of presentations. I'm putting up across, for example, now I am more interested in how can I put my data in a more understandable way to my audience. That being the case, I don't want to be spending time determining how it should be run with the given hardware. Now for me, that is taken care by Windows and the device drivers that exist on my laptop. So again, the same example, I am able to concentrate on things that matter to me rather than those things which actually do not add any business value to me. Similarly, in these layers, you choose an ECU, then the same ECU provider, the microcontroller provider, will actually provide you the microcontroller abstraction layer or the MCAL layer. Then you actually ask someone like a Vector or Electrobit to provide these blue-green blocks or violet, green blocks, whichever color it is. That is what is called as basic software, BSW. Now, the BSW integrated along with the microcontroller abstraction layer together is what forms your complete middleware stack or the AUTOSAR stack. And then in between here is the runtime environment of AUTOSAR, which is actually the most crucial thing that an AUTOSAR integrator needs to understand. The application layer is going to interact with the layers below RTE, the service layer, or they are going to interact with each other. The application layer consists of lot of software components. As I said, they are all going to talk to each other, or the software components are going to talk to the service layer through this runtime environment. Your runtime environment is actually like your electrical socket on the wall. What is behind the wall is really not necessary to you. All you need to know is you need to have a 3-pin that you can plug into the socket and start getting the electricity from there. Similarly, your logical component can be plugged into the runtime environment. You can map the signals and then they can start talking to each other. I'll show you more when we discuss about the virtual function bus going forward. This is a detailed way of looking at how the AUTOSAR architecture looks like. Here, as I said, you can see there are a lot of application software components which are nothing but software logical blocks, and they're going to talk to the layer below, or they're going to talk with each other using the runtime environment. So what exactly is this virtual function bus? Now let us say, I'll give a very subtle example. Let us say this block SVC1, software component 1, is something that's going to take two numbers, add them, and then give the result on this particular port. Now let us say SWC2 is somebody who wants to use the result of that addition that was performed by SWC1. Now if you see here, the SWC1 has something called a send port. It has a sharp point. You can actually, by looking logically, make out that it is trying to send something. It has a send port. Now software component 2 is going to have something which is of a inverted V shape, which is nothing but a receive port. Now every vendor like Vector or Electrobit or KPIT or even whoever you are using, in their tool chain, they are going to allow you to make connections the way you make in MATLAB on the RTE layer, or if you are a vector user, you might have heard of DaVinci Developer. So in that you actually create this software components and you actually do the signal mapping, where you actually connect the send port that you have created on software component 1, take that and then connect it to software component 2, which means something that is sent by software component 1 will be used by software component 2. Similarly, if there is software component 3 which still needs this addition, you can create one more receive port of the same type and you can connect the data from the same send port to another receive port here. So one send port can be connected to multiple receive ports. The next thing we're going to talk about is a client server port on our software components. Client server port, as in any client server communication that we know, take internet for example. If your laptop is the client and let's say Google is the server, what you're going to do, your client is going to ask for a certain service. If you type in a search and ask the Google to search something, you're going to send that request to the server and then the server responds back with its result, which is again going to be displayed on your client. A very similar communication happens either between two software components, or more importantly, a software component is going to talk to the layers below the RTE, usually using the client server communication. The layers below the RTE, the AUTOSAR basic software, will provide lot of services, as I told earlier, in the form of APIs. Now if one of my software component need to get access to that API, I'll give an example. Let's say if we are talking about COM and I have a CAN signal that needs to be written into one of the CAN message, I will have to have access to that particular CAN signal and write it. Now that I need not do as in classical software. There will be a service provided by the layer below the RTE which will say com underscore write signal so on. So now my software component just needs to get access to that particular service. For that I'm going to create a client port and then connect communication. The communication stack is going to provide me a server which will already be in my system integration package. So I'm going to connect these two, which means my software component is going to get access to all the services provided by the COM module. In that case, I'm going to get access to the API to write that particular signal, and then I can just directly go ahead and use that API in my code to write that particular signal into my CAN message. So that way my software component communicates with the layer below the RTE using the client server communication. Also, it is possible that, let us say, one of the software component has a multiplication function which you want to give access to another software component. You can actually make this software component a server the way it is depicted here, and then you can create a client port on another software component, connect them so that this component gets access to that multiplication service provided by this component. Now this is the client server communication. Now coming to the fact, why is this whole thing called as a virtual function bus? It's basically because by connecting the send port, receive port and client port and server port, there is signals and data that is being exchanged between different software components which are logical blocks, or between a software component and the lower layers of AUTOSAR. Now there is actually no physical bus that is connected, but still on a behavioral terms they behave as though they have been connected through a bus. There is a functionality that happens in combination of these blocks as though they are connected through a bus, and that is exactly why this particular concept is called as virtual function bus. There seems to be a bus even though they are not physically connected. There is a bus at the software concept layer which is not physical but is virtual. So that is why this particular concept is called virtual function bus. The virtual function bus is actually the orange block you see is nothing but the runtime environment layer. All the virtual function bus find its connection through the runtime environment, which makes the RTE far more important when it comes to use in OEMs or tier 1s who act as the integrators of the whole system. Now I'm going to stop this particular session at this point. There are lots that we can discuss going forward. We can talk about the SWCs, internal and external properties, what can be done, how they can be configured, etc. And then furthermore advanced, getting into the layers of AUTOSAR, what can be configured, what are the things that could be configured within that, etc. But since, as I said, this is a very basic introduction to the concept of AUTOSAR, I stop at the virtual function bus as a concept. Please let me know your feedback on this particular session, and if you intend to know more on the concepts of AUTOSAR, please leave them in the comments and I'll try to do my best to bring them to you. For now, bye bye, have a good day, take care.